Hello and welcome everyone to this IT Pro webcast in association with IBM. My name is Stephen Pritchard and our topic today is cognitive computing and the office of the future. And we'll be looking at how those two elements are going to work together and change our working environment. It's quite interesting to see how computing technology has evolved over the few sort of generations that we've been with it now. We started off with very simple machines that could do tabulation and adding. We moved from that into the programmable computer, the client-server environment, and now we're in a world of big data analytics and even artificial intelligence. But perhaps the most significant development coming up is cognitive computing. Now, computers have always been well known for doing repeatable and often very simple tasks very, very quickly. That's the building block of a lot of computer science, of course. But cognitive computing takes it to a whole new level. We're looking at systems that can interpret information and provide advice and assistance to human beings in what information we need to act on, and help to cut through some of the clutter and data that we have to deal with in the business world today. It also could help us to perhaps be more efficient and more effective as organizations. So in this session, we'll look at how cognitive computing is developing, but we'll also examine its place in the workplace and how business applications might actually evolve in a world where maybe not computers thinking of themselves comes along, but where computers can help us to think more clearly and more accurately and make better decisions. And joining us we have from IBM, Stuart McRae, and we have from the industry analysts, Quocirca, Clive Longbottom. Gentlemen, thank you very much for joining us. Firstly, we are happy to answer your questions, so do please send those in as soon as you can. You can do that via the interactive panel on your screen, or you can do that via Twitter. We'll be looking out for Twitter, but do use the hashtag #CognitiveWebinar. We're also keen to get your feedback on how we're doing today, so there will be some opinion polling at the end. Give us your feedback on the topic and also your chance to give us your views on how you think we've done. So again, do look out for those and they will be up on your screens after the Q&A. And having said all that, I would like to now introduce our panellists formally. Stuart McRae of IBM and Clive Longbottom of the industry analyst Quocirca. Would you just like to introduce yourself? Stuart, just tell us a little bit about your background, and Clive then if you could just follow.
Sure, yeah, so I'm a collaboration evangelist with IBM. So my role is basically to understand the future, what's happening, best practices today in applying collaboration technologies particularly. I've spent 40 odd years in the industry, always working on the area of how people use IT technology to collaborate with other people.
And Clive?
I'm Clive Longbottom. I'm an industry and business analyst with Quocirca. I've had proper jobs in the past where I was at the sharp end working within organisations doing real stuff. Then I moved into IT. I've worked as a consultant and then as an analyst. And what we're looking at within Quocirca is the impact of emerging, maturing and continuing technologies on businesses. The only point in having technology is to help a business. It's no longer the case of being the magpie of, ooh, that's shiny, how can we use it within the organisation?
Absolutely. Well, what I think we should do to start off then is to break down the question that you can see in the background there a little bit and split it up into two. So we've got 2 points there, the office of the future and what that would look like, and cognitive computing and what that actually means. So Stuart, just to start us off, from a computer science point of view, from a theoretical point of view at least, what do we mean when we talk about cognitive?
So looking at the theory, cognitive systems and the way they differentiate from traditional computer programs is they do 4 basic things. They understand in the same way a human could understand unstructured text or a video or other content. They reason about it. IBM's work in cognitive starting with us building a computer to take part in a general knowledge quiz on television and then just reason and figure out the answer to questions. It learns as it does that and learns from the feedback it gets and new sources of data. And the third thing, and then fourthly, it interacts with people. But it interacts with people in a conversational way, not a traditional IT way. So it's really about things like bots, being able to answer questions, being able to speak to people. We will end up eventually with the Star Trek computer. You can ask a question and get the answer vocalized back to you.
Eventually, but maybe not quite tomorrow. But Clive, from your perspective then, how would that affect the way we organise the place of work? Well, that's what we're talking about here. We're looking at how the office of the future will be affected by this and where this type of technology might initially find an application.
Yeah, I mean, the obvious place is in the customer-facing environment where you really are looking at, you need to be able to respond very, very rapidly to any customer request. Now, if you just leave that up to the human and you have standard big data systems sitting in the background working against a set of known rules, you will occasionally get information back, sometimes reasonably slowly, which is wrong. And you are dependent upon the customer agent to be able to realise that is wrong and be able to respond to the customer in a way which the computer is not telling them to do. With cognitive systems, you've got something which thinks like the human but operates at many thousands of times faster. So it should be able to come up with not just the one response, but here's a range of responses with the possibilities, probabilities of how accurate these are, to then allow the human brain to look at those and go, that is the one which the customer is really asking about. I can put that forwards to them. If they say, no, you're not understanding what I'm asking for, I've got other stuff, and I can then put that information in, and the cognitive system learns and comes back with a new set of responses to me. So, you know, this helping system of something which sits alongside the human and enables them to respond far more efficiently, effectively, accurately to what is being requested of them, whether it be a customer, whether it be another person within the organisation, whether it be something just asking for inputs. You know, that's where I think we'll see the biggest impact in the shortest term.
So to a great extent it's a filtering system. But Stuart, just bringing those two strands together then, if we bring the idea of cognitive computing together with what we can already do around the office and the type of sophisticated systems that we already have in the business environment, what would you start to look at? What type of instances and applications would you anticipate?
So some of the early areas we're working in for collaboration is really helping the individual do their job, process their email inbox or research information in documents they need, etc. So it comes down to two broad categories as our starting point. One is the personal assistant. You receive an email from someone asking for some information. Instead of having to go find that information, copy a link, put it into an email, send it, the assistant can create a pre-formatted email saying, I think this is what they're asking for. Here's a canned response with the attachment. The user can then check it very quickly, especially on a mobile device. It's much easier to read that, quickly review the document, say that's right, send it. So that idea of a personal assistant helping you work more productively. And then secondly, the expert advisor, because what biggest problem, if you ask the average office worker today, is information overload. There's too much information out there. If I could read it all, I could do my job way better. Well, the cognitive system can read it all, understand it, and reason from it, and then answer your questions about it, again, to give you information. So then you can go and investigate further, look at specific content, or you can simply make a decision and move on. Make people more effective, more productive is really what we're talking about.
So this idea of a virtual digital assistant that could be applied in different business scenarios. Clive, this idea then of augmented intelligence rather than artificial intelligence, and how would you distinguish between the two?
The idea with artificial intelligence is that it replaces the human. Now, what we're moving towards is not the same number of jobs, the same number of people doing the same type of jobs. We have already automation, which is being able to codify a set of processes according to a set of rules and moving the carbon-based life forms out and replacing them with the silicon-based life forms, which, you know, can do the same thing hundreds and hundreds of times and will never make a mistake, whereas a human can do the same thing 100 times and then on the 1001th can get it wrong, and you don't want that. So now, you know, artificial intelligence would be saying, well, we can get rid of the human completely. We can replicate all the thought processes. Augmented intelligence is saying, no, the human is still, the brain is something which a computer is nowhere near replacing. It does things in a completely different way. A human can look at something and see that one burst of, wow, that is what it really means. But the augmented intelligence, the cognitive system, can look at a whole raft of different types of information, go through it and can make sense out of it far faster than the human can, and can present that to the human, who then can make that wow decision far more quickly, you know, because they're getting all of that condensed, précis, thought through information presented to them in a way where it does make sense. And it's far more than just what we've had in the past being the business intelligence, business reporting, business analytics. You know, that again is looking for patterns. What we've got with cognitive is it's looking outside of the patterns and making sense of something which hasn't got a pattern in the first place.
So is it best able to cope with structured information, or can you equally apply this type of machine learning to unstructured information? As businesses are increasingly concerned about the volume of unstructured information that they have to hold and process.
Yeah, I mean, the whole idea with cognitive is it's got to be able to deal with anything that's thrown at it. So, yeah, at the moment, it's a big data issue. So it is saying, okay, yes, you can throw all of your information that's being held in your CRM system and your ERP system at me. I can deal with all of that. Throw all of your documents at me, and I can go through all of those and make sense. I'll do a few Google searches and ingest all that information and make sense of it as well. And as we go on, it'll be voice and it'll be video. All of those will be taken into account as well. So it's still down to computing power. As we're looking at more as a service type cognitive systems, then that compute power becomes far greater than any one organisation could put in place itself. So yeah, we are moving forwards all the time, but we need to make sure that we don't fall for the siren cry of artificial intelligence, being anything from the HAL computer through to the stuff that we see in iRobot and so on, and start to look at this as being a case of, no, this is how we work together with the capabilities of a cognitive system to make life easier for everybody that's concerned.
Keep the AI on the bookshelf under science fiction for the moment, maybe. But Stuart, at a practical level, how does this change the way that we'll design enterprise applications? And indeed, as we're talking about making the workplace more productive, how potentially might we change the way that actually we design business processes to take advantage of this new capability?
So I think you've really got to look at this from two perspectives. There's the evolutionary side. How can you make what you do together better, evolve that and improve it? And then how can you address new problems, new issues, major pain points in a new way? The second thing to really understand is cognitive, it's happening now, but lots of other things are happening now as well. And it's in the landscape of a much broader technological evolution. So Clive was talking about the amount of computing power necessary and the fact it's hard for organizations to build that up, especially if it's only needed occasionally. This is happening at the same time as cloud. It's clearly something that's happening in public cloud right now. IBM is delivering its solutions as public cloud services, as API levels. Interesting things are starting to happen in how the cloud is changing. So we're talking about application. If you think about this, the cognitive side is doing the reasoning. That could be happening in the cloud while the data is entirely on-premise and just being provided through as needed, and the applications which take action based on the results of the cognition may also be on-premise. So the whole evolution of how cloud technology is working, clearly because it's able to simplify the interaction with the user, we're going to see mobile phones and mobile devices and spoken interfaces, the headphones people have in their ears as being their primary interface, potentially pretty rapidly. So the mobile cloud analytics, as some parts of analytics complement what cognitive does. Maybe it's only a small piece of the solution, and analytics is doing most of it. You can bring all of that together into enterprise architectures to address business issues. It's not just applying cognitive as this sort of standalone thing separate from the rest of IT.
Yeah, it's the right tool for the right job. Automation has still got a big part to play, and by using automation as sort of this first filter, you end up with less information that needs to be put through into the cognitive environment, and so the cognitive environment can be far more focused on the job that it's set up to do. And one of the big problems that IBM found when it first started looking at Watson for healthcare was a case of, people are expecting, or there is a perception that with the way it worked in Jeopardy, that this would be a case of, I've got a pain in my ankle, and it would come back and say, all right, this is the problem that you've got and this is what you need to do. But that first iteration had to be a case of, no, we're dealing with a small subset of cancers, because we cannot deal with all of that wealth of information that there is around everything to do with healthcare and give a response where we can say it's 80% probable, 90% probable. And I think this is where a lot of organisations are going to have to look at and say, what is it that we really want to focus on? What is it that's costing us money? What is it that's stopping us from being so competitive in the market? And let's make sure that we use cognitive to deal with that constrained area, because that's how we'll get the most value out of it.
That's a good point, and it comes back to this question of filtering and providing decision support services to the human element as well, which we'll come back to. I will come back also to what you were saying there, Stuart. I thought that was very interesting about where the technology needs to be located. But just a reminder before we do that, do send us your questions over, and please also look out for the polls at the end of the session, and there should be some material for you to download from the console as well after the webinar, the live webcast finishes in about half an hour or so do keep an eye open for that. But Stuart, you're making the point about whether to locate on-premise or off-premise. And I suppose that does again come back to the business process and whether you can design the business process in a way that allows the time it might take to send data off and then bring it back. And that may be a very small amount of time, maybe minutes, but it still needs to be built into the process. So maybe in, say, R&D or researching where to drill for oil or site a wind farm or something like that, it doesn't really matter if it takes overnight necessarily, whereas if customer services, if someone's using social media to interact with business, it needs to be straight away. Maybe that's a case for having it located more closely to the point of the service itself. How do you see that developing?
Or to storing the data itself in the cloud in the first place. And cloud-based data services, separate from cloud-based cognitive services, are happening at the same time, and bandwidth is getting faster. So I think this is about how IT itself gets restructured and reorganized over time. If we look at even how applications are being built, we've moved from the mainframe era, where it was a large lump of code, a program, to distributed computing, where it was several applications, client server, to service-oriented architectures and a whole set of loosely coupled processes coming together to build a business process, to today microservices. And that's really what we're talking about here, that the cognitive is a set of microservices that can be invoked by some higher level application.
So we're going to be driven by APIs into existing applications. It may not necessarily be that IBM makes those applications. It may be a product that you provide or a service you provide to others.
Absolutely, and that's the big change that happened after. So immediately after the Jeopardy experience and Watson, the technology became available, IBM started building applications in healthcare, and as Clive said, we could only focus on limited areas. We had the resources to do that, and that's when the light bulb went off, and we said as an organization, what we need to do is expose Watson as a set of API services available in the cloud that anyone can use to build business applications. And now we have thousands and hundreds of thousands of companies all building cognitive applications using our back-end services.
Yeah, so Watson is the name that was given to the system built for the Jeopardy competition, but it's now the umbrella name for the cognitive work you're doing.
Yeah, that's correct.
But how does this then just compare to the current generation of advanced analytics and business intelligence? Because it seems to me that at one end, the distinction is quite small. It's almost a continuum. Some of these very advanced analytic systems actually may look cognitive to the person receiving the results.
Yeah. So I don't think it matters. The whole point is it's a set of services that let you build applications that do stuff, and some of the services you use are what we would have known as analytics a few years ago. Some of the services that you use are cognitive, some are kind of hybrid in between maybe. You're just accessing those services to deliver a solution. What happens under the cover, you really don't care. I challenge anyone to if they were able to do it, which you probably can't, to look at all the apps on their iPhone or Android phone and say which of these apps are actually using cognitive services at the back end. You wouldn't know. They're just delivering something to you.
It's quite amazing. If you go into an organisation, if you go into a badly performing organisation and ask them what technology they're built on, they'll be able to tell you. If you go into a really well-performing organisation and ask them what technology they're based on, they can't tell you, because the technology is doing what it's meant to do, which is facilitating what's meant to happen. And because it is doing that facilitation, then it's hidden. It's not visible to the user. If it gets in the way all the time, if they keep on seeing the logo of the software that they're using, that the operating system keeps on rebooting and all that sort of stuff, then yes, they'll tell you. It's that which is holding us back, that is not allowing us to go forward. And if it's a case of, no, the process that I started off went through all of the different parts of that process, each of the task workers did what they were meant to do, they had the right inputs, they provided the right outputs, and therefore we ended up with a shed load of money at the end of it, and we all got paid on the Friday, and we had a bonus when it came to Christmas. They don't care what the technology is, and that is how the technology companies got to start working towards, and that is, look, use this because it fits in with the required outcomes that you're aiming for.
I just wanted to touch on something that you mentioned earlier as well, though, Clive. This question of decision support, which is very much in the example that Watson you gave in terms of the medical sphere. But how critical is that to the adoption of cognitive technologies in the workplace, where actually we're not asking computers, and we said this right at the start of this session, we're not asking computers to make decisions. What we're doing, hopefully, is helping human beings to be able to make more decisions and better decisions. So how do you see that working in practice?
Yeah, if you get a system which is totally prescriptive, so it comes up, the person who's wanting to use it is sitting there, and it comes up and says, right, this is what we found out. Just one solution, here you go, take it or leave it. A lot of them will leave it, particularly if it hits their cognitive dissonance. That is, that they're sitting there, they have a set of inbuilt beliefs, something comes up, and they're looking at it and go, that goes against all of my internal beliefs, and therefore it must be wrong. So what you need to be able to do is to give them, we've looked at all of the available data, here are the top 3, 4, 5 possible solutions. The top one is 95% problem, the next one is 80% problem, 70% probable. Then they can look at it, they can drill down to see what has supported all of that. That can help to fight their dissonance. If they find that the top 5 are all against what they believe, they're far more likely to go, maybe I am wrong, rather than just having the one. So it is making sure that the system is not prescriptive. It does not tell them what to do. It advises them what to do, still makes them feel that they have that final say, that they are still an intelligent part of this whole process.
Yeah, no, definitely. And again, we've seen that, haven't we, where there's been resistance in BI and analytics more generally to conclusions that the system produces which go against the received wisdom of the human managers, and it's sometimes hard to get people to buy in. So it's a very good point about how you would actually apply this in practice, and it's much more around how you manage your people and how you manage your business processes than actually what the technology is doing.
Yeah, I mean, the same as always, don't throw money at a solution and then say, we've solved it. People are still part of that. You do have to go through all the standard change management. You do have to listen to them, not only before you put the solution in place, but all the way through as they are getting to terms with it. Listen to where they believe it's not working for them. Listen to where they go and say, actually, if we took this 2 stages further, we believe it would be able to do this much more. It's an ongoing process. It's not something where it's a case of we didn't do it beforehand, we've now done it, we can look at something different.
One of the really interesting areas where cognitive is being applied quite early is in HR, in understanding your workforce, managing your workforce better, figuring out if you have the right skills, figuring out who the people who are vulnerable to attrition are, figuring out how to train people better, to put them through the courses they need to go through, to assign people to do succession planning, a whole series of things in HR to make your workforce more effective and to enable the workforce to go through the sort of changes they need to go through, can actually also be enabled by cognitive technology applied to HR data.
Is it also, though, a case where a lot of the applications are in data-intensive industries? So we talked about, for example, oil and gas distribution, energy distribution, those type of things, where there's a certain amount of scientific endeavour needed and there's lots of information that needs to be processed.
Actually, I think what is true is it's going to be most valuable in content-rich industries, which isn't the data-rich industries you were talking about, because you're talking about structured data. There's lots of structured data in those industries, but it's how does a marketing agency understand the impact of the vast amount of conversations happening around their marketing content. It's about organizations with thousands of policies and best practices documents that no single person could understand, but an expert advisor can tell them whether they're doing the right thing or doing the wrong thing and point them to the sources.
If we take a relatively simple example, there's a toy manufacturer called Chatterbox who's using Watson natural language processing. Now that is for 3 and 4 year old children. If you've ever sat down with a 3 or a 4 year old child and tried to figure out what it is that they're trying to communicate with you, it can be very difficult. But they're building this into the toys, listening to the child and being able to give responses which are far better than the pull the string out and come back with it saying, to infinity and beyond. That's the sort of thing that's happening. And then if you look where the biggest growth areas are at the moment, if you look at something like Alexa or Google Assistant, these are moving into the cognitive environment where it is just a case of, hey Alexa, what's the weather going to be like today? Oh, I've taken an umbrella with you, that sort of thing. But as you start to bring in that Alexa can deal with Hive, that Alexa can deal with your Philips light bulbs and all the rest, it's then getting to this level of, it's not an if this then that rules-based engine. It's going to need the cognitive to be able to say, what is this person actually trying to get me to do?
Yeah.
That's where we need to take a bit of a leap of faith or a bit of a step into the unknown, because that's not tended to be how we think of IT in IT departments. Just a quick reminder as well, again, about the questions. Do put the questions. I can see a few coming in already, but if you do want to put your question to the panel, please do that as soon as possible, and don't forget our feedback polls at the end as well. So we've only got a couple of minutes left, actually, to round off the conversation, and I just wanted to really address the question of how we put this into practice. So really looking at how the technology might be used within a business, and in fact who might own the technology in the business. Is this going to be a horizontally distributed technology in the way that client server has been, in the way that perhaps mobility is in the enterprise today? Everyone taps into it, takes what they need from it. Or is it going to be more specific? Is it going to be targeting particular business problems? You talked, Stuart, earlier on about pain points, and systems which are designed to tackle, at least in the first instance, a really thorny problem. Then maybe if it's successful, it will be rolled out more widely. Where do you think it will go?
So I think that's all tied into the evolution of IT departments and how enterprises do IT, right? So I think where you're really going to see this emerge in the earliest days is as new capabilities appearing in existing applications. So I work in the collaboration solutions business. We think about, so how can an email client get better by using cognitive? How can a social engagement platform for employees provide insights through to HR based on the conversations employees are having? How can we use cognitive in order to extend the capabilities of existing business applications? There's another segment where a CIO has a particular problem the business wants it to solve, and they can use cognitive to do that more effectively. Those projects are definitely going to happen, especially in the area of differentiating and being disruptive in industries. But the main adoption is just cognitive capabilities are going to start appearing in the applications businesses already use. As
you already said, it's in a lot of things on our phones already. Clive, is there a case for being an early adopter, or is there a risk of being an early adopter in this space?
Typical analyst answer, yes. I think a lot of the adoption is going to be in the same way as quite a lot of technology has been in the past. It's going to happen to you anyway, because of the way that this will predominantly be an as-a-service back-end solution. If you go to a third party and say, can you come up with something that does this? Then if they choose to use a cognitive system at the back end, you'll be using cognitive. As Stuart has already said, a lot of companies are already using it. They just don't realise that they're using it. And I think it's again this morphing of the role of the IT department, which is no longer a case of, yes, we've got 50 people who know how to set up an Intel server, what an IP address really should be, how it interacts with DNS, what we do when it needs rebooting and patching and all the rest of it. But a group of people who are sitting there saying, right, this is what the business says it needs to do. These are the different ways that we can do this. We can do it on-premise, we can do it as a service, platform, infrastructure, or we can do it as software as a service. These are the costs that are involved with it. These are the risks that are involved with each of these. These are the different values that they all bring in. Now, business, based upon your own risk profile, which one of these do you want us to make happen? And that changes the whole way that people look at doing things, and that, I think, is where it's just a case of, right, so yes, cognitive just happens to be a part of all of these three options that we're providing through to you, because it's the best way to solve the problem.
So it's just there as a tool.
Yeah, and then when we were warming up for this webinar, you yourself quoted Arthur C. Clarke, and his vision of advanced technology is indistinguishable from magic. And actually, that's true of technology today. You use an app like Shazam on your iPhone, it suddenly tells you what music you're listening to. It seems like magic. Add cognitive in there, the magic just gets a bit better, right? But to the user, it's still all magic.
I do have to just put you on the spot, though, finally, Stuart, because we are a business publication at the end of the day. What's the ROI on this? What would be the justification if I went to my board and said, look, I want to invest in magic? I'm not going to get very far. How would you position the case for making maybe an initial step towards cognitive computing to the board and
actually,
an ROI?
I think if you could really do magic, you probably would get a lot of traction with the board. So I was talking to a business yesterday, and they were discussing the challenge. They have lots of data, geophysical data, going back to the oil and gas industry. They would like to share it with people. They think businesses can do really exciting stuff if they had the knowledge but those businesses don't have time to come and have conversations with them. So from my perspective, coming back to where I'm sitting in the collaboration space, I want to free up employees' time to go do more creative collaboration within and outside of the business. And I think other things that are happening at the same time are vastly improving the capability for businesses, employees to interact with their ecosystem and get more done if they didn't spend their whole day going through their email inbox. And that's the problem we can solve for.
So a lot of it is actually about making better use of two resources that we have. So one is our information and the other is our people.
Absolutely.
Excellent, thank you. Well, I will take some questions from the audience now. So I've got a couple up there which we'll see how many of them we can get through. Just taking the one at the top though, Clive mentioned Alexa and Google Assistants. Is there a precedent in industry where these capabilities are being used for more than just personal use? So can they be scaled up to an industrial type of application?
They can, and I was talking to an organisation just last week who unfortunately I can't name, but they are looking at how something like an Alexa environment, if you put Alexa into everybody's office, how that can be used as being the main interface between the human and the back office environment. And with Alexa being an API-driven environment as well, it is a case of yes. So you can have Alexa as the front end to Watson. You can have it as going through to AWS to pull data through from S3, wherever it might be. So it is happening. It's not going to be rapid. I don't suddenly see that you're going to get some heavy manufacturing company going, this is a great idea, let's put Alexa down on our manufacturing process line. There's a lot more to be done around there. But we're seeing this very early stage. But you've also got some of the other projects which are going on when you look at something like Project Oxford from Microsoft and so on, looking at other back-end systems. We need a level of standardization. We need to make sure those APIs all talk in the same possible way. Otherwise, we're going to end up with a chaos that IT has tended to fall into far too often in the past.
And I can see this being quite useful actually as a way of simplifying things. We put a lot of complexity into some of the back-end systems such as ERP, but if we can simplify the front end and say, how do I put more environmentally friendly vehicles into our car pool, this is what you need to do, and it comes back with some pointers onto your internal document.
The CIO of Slack, team collaboration solution, has this vision that he would like, and it's a text-based conversational system, but he would like that to be the access to all of your enterprise data. You should be able to type a question into Slack, which Watson or some other cognitive engine goes, researches and ingests the answer to that question back into the conversation rather than a person having to do it.
Yeah, it's a good vision to have, isn't it? Yeah. So following on from that, how much of cognitive business is about AI and how much of it is really big data number crunching? I guess we've touched on that a little, but Stuart, can you clarify that for the audience?
I think it's difficult. The boundary changes over time. You need the big data, you need to crunch it, and then you need to reason and make decisions based on it. They work synergistically together. They're not different things in terms of the solution.
Absolutely. So, changing tack completely then, what would the office of 5 to 10 years look like? And leaving aside the question of whether there would even be an office in 5 to 10 years, or whether we'll all be on Mars or working from home or working from a third space. I'll ask you first, Stuart, and then Clive, feel free to chip in. But given what we've just discussed and what we know about the way that people are evolving their relationship with technology, where would you want the office to go, and how would you want it to operate?
What I would want is the office to follow me to wherever I go. And therefore the answer is going to be different for different people. Some employees are sitting at a desk somewhere, that is their office, but other employees spend all of their time traveling. If I'm getting on a train or whatever, I'm just as productive in my office as if I'm sitting at a desk. And I definitely wouldn't expect to be using any form of PC or laptop to do my job in 5 years' time. The question is, will it still be a tablet or smartphone type device, or will I simply be talking to my headphones?
Could everything be in the cloud? And accessed via voice?
Given that the cloud is a hybrid thing that spans the public world and the enterprise world, yes.
Yeah, there's interesting things. So much of the physical space that we still use is designed to accommodate the manual production line and from then on the manual typewriter, and it takes quite a lot to change the way that people create those spaces, which allow people to make use of this technology in a more appropriate way as well.
It does. I mean, I'm old enough and gnarly enough that I can go all the way back to the first days of people saying, oh, working from home was really different. You know, working in the cube farm was something which was just coming through open plan offices. You know, you used to be able to walk into any public sector environment and you knew how important a person was by the depth of the carpet. The predictions that have come through have never managed to get to that real point. But the predictions that have been there have had an impact. So we are seeing far more people work from home. We are seeing far more where it's not just a case of, oh, we have the road warrior, sales force, field force, and we have the desk-bound worker. There's all the nomads in between and all the different levels of mobility as well. And I think, you know, what we're now working towards is a system which enables people to work as they want, where they want, when they want. And, you know, this whole idea of the Star Trek computer, you know, we're pretty much there when you look. You know, if we can get Alexa down to that size, if we can get, you know, Cortana and Siri to actually work against the APIs at the background instead of being walled gardens, which essentially they are at the moment, you know, we are getting to this point where, yes, workers will be able to go, oh, I've just remembered something. You know, I'm just having a coffee at Starbucks. I don't have to get the tablet out, worry about that I'm connecting through a public Wi-Fi system and that I've got this data. I just say to this system, which is going to connect through a VPN, naturally it's going to be fully encrypted, and, you know, make sure that nothing can capture all of that data. And I'll just say to it, can you make sure that this happens because I forgot? And it'll make it so.
Again, you know, knowledge workers don't actually want to carry more pieces of technology around. They want to have better access to information. John, we're pulling two questions together here because I think they're related. Which departments within a business are likely to see the most benefit from cognitive and why? And then related to that, is cognitive suitable for all businesses? If we could take the second half of that first, Stuart, industry-wide, where are we seeing it being adopted? We talked about health, but any others?
Yeah, so I think we're seeing being adopted in different ways in different industries. So if you take the obvious one, public sector is very focused on reducing costs. How do you manage calls into the tax helpline or whatever more effectively? And this technology is clearly useful for reducing cost. Then you take a very active, disruptive industry. You can use this technology to do disruptive things to outperform your competitors. So I think the applicability is pretty much everywhere, but there are some. Healthcare emerged very much first. Public sector is emerging very much as a target area. And then don't forget the horizontal stuff like collaboration, which is simply universally applicable. Fraud in insurance is an obvious case. So you more think of the industry, and then within the industry, what are the key problems which can be better solved by this technology?
Yeah. I mean, if you look, Hitachi is doing a lot of work in the mining sector. And rather than just being okay, I mean, the Komatsu trucks that they're dealing with down in Australia, these are trucks that carry 800 tons of waste. And whereas before they used to be driven by some tough Australian guy who would get through a gearbox once a month and would actually crash the thing quite often, they've now fully automated those so that they drive 2.5 inches apart from each other. They can pass 2.5 inches aside from each other, and they don't get through gearboxes any longer. But that's automation and autonomous, which hasn't got a great deal to do with cognitive at that sort of a level. But what they're also building in is being able to say to the whole mine working, based upon geodemographics, based upon weather, based upon all sorts of things, stop mining. You're not going to make any money out of what you're mining at the moment. So stop and wait until, you know, the price goes back up, or wait until, you know, this has happened, and then start mining again. So it's using cognitive systems of bringing loads of different types of information together. And, you know, it's very difficult for a mining operator to go, you're saying we've got to stop doing this? Well, yes, because you're throwing money down a black hole if you continue to do it. Again, that cognitive dissonance of a mine owner going, if we're not mining, we're not making money, to being a case of if we're not mining, we're making more money than we would have been doing. And so, you know, I think, yeah, as Stuart says, it's dependent on the vertical, it's dependent on within that vertical, the horizontal. And you'll see it within the customer service environment, you'll see it within HR, you'll see it within the individual saying, give me a digital assistant.
And the other aspect to that is that these systems can be proactive. If you had to have a bunch of highly qualified analysts sitting in a room and coming up with this decision once every quarter, that's very expensive overhead. And if you send the question off to them to look into it, then it may be too slow in terms of actually giving you business value. Whereas if you could have something like this in the background, which will monitor external markets, meteorology, geology, or whatever it might be, and then pop up with an alert, it may be as simple as an email to somebody in charge saying, you need to look at this, maybe look at production this week because prices are very low or distribution costs are very high.
I think email's not a good idea because it won't get read, but injecting it into a conversation, absolutely.
It could pop up on social media. I mean, I'm sure that could go onto your watch. I'm sure there's lots of ways of communicating.
But I think that cognitive against analytics is where we're really seeing that if you are looking into the future, analytics will have to say it's a straight line or it's a Bayesian or whatever it might be. I've had to apply a known way of analysing this to say this is what's going to happen in the future. Cognitive can take a totally different approach and come up with something which it might be that it might be presented as being less likely than a straightforward straight line prediction would be, but it's likely to be more right in the long run.
I'd love you to get rid of email for me, Stuart. I'm sure most of our audience would as well. But for the moment in business systems, it's probably going to be there for a while. Just a final, maybe a final question, because I'm conscious of time. But what about opposition? There's a fear of intelligent machines. There's a fear of job losses. I'll go first to Clive, and then Stuart. I'll give you the final word on that. But is this a real worry?
It is, and we are hamstrung by political thinking around this, as far as I'm concerned. My view is we should be embracing that we can use automation, we can use cognitive to get rid of a lot of the grunt work, and we can get rid of so much grunt work that we will need fewer people actually doing jobs. Now, we don't throw them into the safety blanket of just of benefits. If companies are in a position where through the use of cognitive and through the use of automation, they're turning out a lot more goods of a higher quality which they can get more margin on, then their profits are going to be a great deal more. We can actually give them tax breaks, give them incentives to employ people to not work for them. And then say to them, well, actually go and do something useful in the community. We are still paying you, and therefore, we can give you a list of things. Choose any 2 of these to do this week that's useful to the community. That then means that there's less of a drain on the public purse, so therefore we don't need to have so much public funding, so we're not looking at taxing these companies so much more. Now that is, it's a complete brain explosion to a politician to try and come to terms with. We're not going to see it happen in the short term. But at some stage, I mean, it is being done up in Canada, it's being looked at in parts of Scandinavia, Australia is thinking about it. Some country is going to do that, putting in place a universal income for everybody, and going to find that it works, and we better be prepared for it. And most Western countries are so far away from that.
A very different vision, but how do you persuade, Stuart, people to accept the technology and, of course, also to listen to what it's suggesting as a final point?
Yeah, so I think, well, it's a question of adoption of technology, and adoption of technology is all about the value that's being given to you. If you had told people a few years ago that they were going to be sharing as much information as they do share on Facebook and others, they'd have said, no, a service like that will never take off. But if it delivers the value back, in whether that's emotional value or practical productivity value, then people will adopt it. The political side is there. One of the challenges that we have is when we look back through history, everything which has replaced human labor has actually in some way improved things from an economic perspective. You look at, okay, all these craftsmen went out of business when production lines were able to produce cars more cheaply, and that's a problem. The craftsmen have to go and do something else, but the demand for cars can shoot through the roof because the price gets lower and many more people are being paid to make cars. And that's happened over and over again with getting rid of secretaries and PCs and automating telephone exchanges right through history. Of course, the fact it's always happened in the past is no guarantee it will continue in the future, but the political system is there to make sure that we create a solution which does address those issues.
So as IT professionals, we have to have the confidence to say, well, this technology may create some bumps on the way, but actually in a few years down the line, we will all be better off.
And be conscious of drawing those moral issues to people's attention so they can put the socio-political solutions in place.
So a degree of openness as well and transparency.
Absolutely.
Yes.
Well, I'm afraid we are out of time. A very enjoyable conversation. I hope that you and the audience have enjoyed it. I'd like to thank Stuart McRae and Clive Longbottom for coming along today and running through this topic with us. I think we'll hear a lot more about this in the future. I'd like to, of course, thank IBM for making this session possible, and to everyone in the audience, on behalf of all of us at IT Pro, thank you for attending.